So now we're going to look at formulas. So instead of just giving you a list or cheat sheet of all the popular analytical formulas for healthcare, we're going to try and utilize the problem approach and then try to address appropriate solution to that specific problem. But as I keep on reiterating, more than one solution for every single problem. So maybe you got different approaches that you would try. Put them in the comments and provide your methodologies as well for everybody to know. But what's very common within healthcare analytics, especially when you got a breakdown of the age that we have, I think it was 10 all the way to 90, is to break it down by age banding. So sometimes it's a 10-year age banding, a 5-year age banding, and sometimes it's just a breakdown of child and adult. So what we're going to do is we're going to go for the last option we specified and just identify the children we have in this data set compared to the adults. So we can use an if function to do this. And Excel is quite good because with any of the functions that you utilize or the formulas that you utilize, they try to give you the specification of what's expecting. So initially expecting a logical test, followed by a value if it's true, which can actually be an additional condition as well, and a value false, which can be an additional condition or the result that you're expecting. So in this case, column B is the one that holds the patient age value. So anything above 18 in speech marks, because it's a text result that we want, we're going to say it's an adult. And then in speech mark, we're going to say a child if it's not true. So there we go. For specific age of 10 is specified as a child. So we're going to double click there and you can see the relative statement is being copied down all the way down, specifying it correctly for the different age brackets. So that's a really good start. The next thing we might want to do is identify unique condition situations. So, for instance, a stroke isn't a common thing in the children. So we might want to put a flag on that to see if a child specifically has a stroke. So for this formula, we might want to combine two different columns values. So we need to understand if the person's a child, which is held in here, and if the diagnosis is a stroke, which is held in there. So let's do that. So CYP stroke flag, actually, let's put child stroke flag. And we can use an if function again, but this time we want to know if this value is equal to child. And we want to not do that. We want to put this within an AND. So an AND function just allows you to combine multiple conditions. And in order for the value to be true, all of the conditions must be met. Or any of the conditions can be met and it will go towards the value being true. So we got our first condition in there, and then our second condition is if the diagnosis is stroke. And at this point, we can enter any value. So we can say, yes, it meets the flag, or no flag. So the first condition is a child with asthma, doesn't meet the flag. And if we do that, we can just put the filter on to here now and see we do have a couple that meet the flag. And in this case, we have two. So they specifically are unique conditions that a child has undergone. So that's another way that we can apply conditional formats in this specific scenario. So let's paint another situation. So I actually notice here that the region is actually patient region and not hospital region, simply because if you were to look at some of the regions or one of the hospitals, you can see that you got Manchester Royal, Southeast London, Northwest London, Midlands. So I renamed that to patient region just to make it very specific and clear, and obviously as part of your data cleansing. But one of the key analysis that is done on a regular basis, which is the direction of travel, especially for the NHS and a lot of healthcare services, is bringing treatment closer to home. So what would be really good in this situation is to identify any activity that's happened outside the local region of the patient. So was the patient close to home or not? Now we have here on this second worksheet tab a breakdown of the hospital region by the hospital. So we got this matrix here that identified St. Mary's in the south, Manchester's in the north, Leeds in the north, and then the other three hospitals are in London. So how can we go about solving this problem? Well, one way, let's just remove the filters. And what we're going to do is just hide a couple of columns just so that our comparisons can be visible. So what do we want to see? We want to see the patient region. We want to see the hospital name. And then we're going to have, actually, let's bring the hospital region within this specific data set. How are we going to do that? Well, we can use the famous VLOOKUP, although there's XLOOKUP, which is multi-directional and probably a significant improvement on XLOOKUP. VLOOKUP is still used quite a lot, so we'll just use that for now. So VLOOKUP here gets the specific lookup value first, goes onto your table array. Now, one of the limitations of VLOOKUP is that it expects the lookup value to be in the first available column. So always bear that in mind that if we were to move this over there, that wouldn't work. But XLOOKUP doesn't have that issue. We supply a column index, and that specifically just highlights where is the return value. And then finally, you can provide an exact match or approximate match. So we tend to go for an exact match because we want the exact hospital, but approximate match can work if you're looking for something that matches it to a certain extent. So for this specific example, we can see, so it looked up St. Mary's and it's identified within our table array that it's in the south. Well, let's use a relative statement going down and we get a bunch of errors. So what's happened here? So essentially, it's because we've just told it to use the relative statement, it's going down and changing the cell values as we would expect it to do. However, we don't actually want the cell values to change in the table within the hospital profile. We want it to remain the same because if we go back to the hospital profile, we see that actually our values end at B7 and start at A1. So we just want it to be frozen there. So an easy and simple way to do that is just to put $, which freezes the row. So the rows won't change. And because you're not changing columns, the columns will naturally won't change. But if you were, you could put $, in front of the column as well. So let's do that. And we'll do this again. And you see that it's remained the same with the table array, but it's allowed the first lookup value to keep changing and it's provided a value where we expect it to. So that's really good, but that doesn't actually answer the question we were trying to answer is if patients are receiving their care close to home. So just looking at these two different hospital region and patient region, what we can notice is that actually south can refer to southeast, north can refer to North Yorkshire, London can refer to London. So if we were to find the south value within here, we can say in this instance that they're receiving their care within region. And then if it's not within region, we can say it's outside region. So let's add in another column and we'll call it, what can we call it? In region activity. And we can use for this one the search functionality. So the search, well, you provided the text you wanted to find. So we want to know if it's in the south, and you then provided the text within. So that's the basically the column that you want to look at or the text that you want to look at and find that specific value in. So you want to find south in that column. And then the start number is just where you want to start, but it's not necessary for this one. So for the first one, it's giving us an error value. Now the search, when it doesn't find something, just gives you an error. But if it found something, it would give you a 1. So let's factor that in and put it within an if condition. So in this specific case, we're going to put it in an if error condition. So that's if error, say out of region. So basically it hasn't found it. It's giving up a value error. So that basically indicates that it's out of region. So that activity occurred out of region. Very good. Or in this specific case, the patient was from out of region going into the hospital, just to make it very prescriptive, the answer. Now, this doesn't completely fulfill our requirements because we get one and out of region, which isn't a nice categorical view of it. So we'll put the whole thing under another if condition. So if this equals 1, then we can say in region. If not, we'll say out of region. So let's look at this. So the first value is given as out of region because the patient is from Northwest. So in an ideal world, the patient would have received their treatment in a hospital that's in the north. So we'll go down a full relative statement, and let's just make sure we're getting the right answers. We'll put the filter function back in, and we'll just click everything in region. There we go. So London, north, northwest, southeast London. So it's working as intended. So basically all these patients were treated in region. Let's see how much it is. Let's look at our status bar. We see that actually it's 27 admissions were treated in region out of 100, which is because if it's 100, it's beautiful maths, and that's 27%. Awesome. So we've been able to solve quite a few problems using different functions and formulas, which is really good. So we'll just make a quick summary table here. Obviously not ideal to have it within the data set, but we just gonna do a couple of different formulas here. So we want to know what's the average length of stay overall. So we can use the average function. Let's just remove that for a second and unhide the values that we need to see. Let's do an average. So we'll figure out what the average age is. So this is mean average. So we got an average age of 52, average patient age. Let's figure out what our average length of stay is as well. Actually, let's figure out what our total length of stay is. So we can use the sum function for that. So we got 760 length of stay in all of our patient data set and an average of 52 patients. Let me just scroll a little bit to the right as well. Now we can also use sum ifs and average ifs, which combine the if functionality with the specific aggregation of a sum or an average and the count as well. So we'll use the count if just to mix it up a little bit. So count ifs is looking for the criteria range, the specific criteria, and then it's going to do the count. So what do we want to specify? Let's count if the patient is from Southeast and in region. What about that? Let's do that. So we'll do that. We'll highlight the column. In an ideal world, you just highlight the data set columns. If it was in the table, it'll just specify that specific criteria name. And we want to know here if they're from the Southeast. So that's the criteria to search for. And we also want to know if they are an adult and if they've been treated within region. So what it'll do, it'll check if the patient row is an adult. It'll check if the patient is within the specific region of Southeast, and it'll check if they were treated in region 5. So what we're going to call this, adult patients treated in region from the South. So that's cool. So that's a really good summary table where we get the average patient age, the total length of stay of our data set, and then the additional bonus of how many patients from the Southeast that were treated in region. So that's a really cool way just to summarize the data and the lesson. Another thing that you can add is also daytime functions, which are super useful. And we'll just do an example one here. So let's say last time in hospital. So the last time in hospital would have been when they were discharged. So you can use equal and you can say today, take away the last time they were hospital discharge day. And you can see that it's thought that the result is a date, but we actually want to know how long it's been. So we're going to put a data format, and it's been 415 days since that patient was in hospital from today. Obviously, we know the majority of our data set is 2024 data. So it's going to be a long time since they've been in hospital in this specific data set. So that's cool ways to solve different problems using different functions and formulas. Hopefully you've learned something there, or you've reminded yourself of some of the functionalities and the beauty of utilizing different formulas. Like I said, there's loads of cheat sheets available. So utilize it, but a lot of the thinking and the concept and the problem solving tends to stay the same. Just apply it to different scenarios. So you can actually get some very extensive formulas just combining some of the things that we've done right now.